Welcome to Day 2, Video 2. In this video, we're going to use the nth term test for divergence of an infinite series. The nth term test is the most widely used test that we use. I think you've noticed on your homework sheet that we're going to learn 10 different tests. The nth term test for divergence is the test that is the first test that we use to determine if a series diverges. In your notes on page 5, you will see that a term converges only if its limit is equal to 0. However, that does not mean that just because the limit is 0, it converges. But if it does converge, the limit as n approaches infinity has to be 0. Let me say that again. In order for a series to converge, its limit has to equal to 0. But just because the limit equals to 0 does not make it converge. But if it does converge, its limit will be 0. And that brings us to the nth term test for divergence. Notice that this test can only test for divergence. It cannot test for convergence. We use this test because it's quick and it's dirty. We use this test to eliminate the possibility of divergence. So this is like a pre-screening test. We have to use this test, and if the test tells us that it could possibly converge, then we have to use another test to test for convergence, okay? But if the test fails, then we know it diverges. And the test says if the limit is anything other than 0, we know for a fact it diverges. So it can only test for divergence. That's important. I'm spending time here because that's really important. The nth term test for divergence can only check for divergence. We take the limit. If the limit is not 0, then we know it diverges. If the limit is 0, then we use another test. Okay? So, the nth term test for divergence states if the series is not equal to 0, if the limit of the series is not equal to 0, then it diverges. If it's equal to 0, then we have to use another test. And at this point in your math career, the only two tests you know are geometric and telescopic. You're going to learn more tests after that. But for now, what we're going to do is we're going to take the nth term test. If it fails, then we're going to ask, is it geometric or is it telescopic? Let's do these examples that are not found in your notes. But take a moment to write them down. Okay? So we're going to determine if the following converge or diverge and state a reason for our conclusion. So these are not in your notes, but there's a nice little white space at the bottom of your notes that we can use. Sorry about that. Okay, so what we're going to do is we're going to start by taking the limit as n approaches infinity of n plus 1 over 2n minus 1. Now, as we take this limit, we see that that limit would equal to 1/2. Because the limit is not equal to 0, we know that this diverges. Okay? For this example, so we would say this diverges by the nth term test. So diverges by nth term test. In this example, we have the sine of 1 raised to the nth power. Well, we have to decide what is the sine of 1. I don't know the exact value for it, but I know that it's less than 1. So I have some number less than 1 raised to the nth power. What will that do? If I have a fraction raised to the nth power, the limit as n approaches infinity is equal to 0. Sine 1 is a constant, so you could use your calculator to find sine 1. As a matter of fact, I'll do that right now. Just on my handy-dandy calculator, I'll do sine of 1, and that is 0.841. So I have 0.841 raised to the nth power. Because this is less than 1, as I take the limit as n approaches infinity, this goes towards 0. Now, just because it goes towards 0 does not mean that it converges. It means that I have to use another test. And the other test that I would use would be geometric. And the reason I would use geometric, because this is in geometric form. A is 1 in this situation, and R is equal to 0.841. Since the absolute value of R is less than 1, we know this converges. And I would say it converges by the geometric test. Okay? I would take, looking at this one, once again, I would take the limit as n approaches infinity. And as I take the limit as n approaches infinity, I see that that limit is 0. Does it mean it converges? No, it just means I need to use another test. So the only two tests that I have now are geometric and telescopic. Is this geometric? No, it doesn't look geometric. It looks a little telescopic, so we have to figure that out. So we'd have to do our handy-dandy A over n plus B over n plus 3. We get 1 is equal to A times n plus 3 plus B over n. Let n equal to -3. We get B is -1/3. Let n equal to 0. We get A is equal to 1/3. And that, to me, when I write this as 1/3 n, I don't know why I wrote that parenthesis, plus or minus 1/3 of n plus 3. That is in telescopic form, so I would say that this is telescopic, and therefore this is going to converge by the telescopic rule. Notice I'm never saying it converges by the nth term test, because the nth term test will only tell me if it diverges. We're going to the next problem. If I take the limit as n approaches infinity, I get the natural log of 1 over n. As n goes towards infinity, this goes towards 0, and the entire thing goes towards -infinity. Since my limit was not equal to 0, I can say that this diverged by the nth term test. My second problem, once again, I'm going to take the limit as n approaches infinity. When I take that limit, I see 3 to the n grows faster than n cubed, because this is exponential and this is a polynomial, and an exponential goes faster than the polynomial, so this goes towards infinity, and therefore the series diverges by nth term test. When we look at e to the -n, we had a problem similar to this today in class. We can write this as 1 over e to the nth power. When I take the limit as n approaches infinity using the nth term test, this will go to 0 because I have a number less than 1 being raised to a fraction, being raised to a power. So that's going to go to 0. I can also see that this is geometric. And my value of r, the absolute value of r, is less than 1 because 1 over e is less than 1. So therefore this converges by geometric. Okay? Again, I start with the nth term test. I take the limit as n approaches infinity. And because 4 to the n grows faster than 1, I get 0. So this can possibly converge. I have to use a different test. Well, I also see that this is geometric. So I can say the absolute value of r is less than 1. So I can say it converges by geo. Converges by geo. I didn't spell that right, I don't think. And our last one, once again, we take the limit. We always start with the nth term test, the limit as n approaches infinity. And inside of this will give me 1. So I have the natural log of 1, which is 0. Now, will this converge? We don't know. We have to use a different test. So I think that this is telescopic. Doesn't look like telescopic, but if I wrote it this way, the natural log of n plus 1 minus the natural log of n. Now does it look telescopic? Because we'll have, when n is 1, we'll have the natural log of 2 minus the natural log of 1. Then we'll have the natural log of 3 minus the natural log of 2, and we can see that it's going to begin to collapse. Part of your homework assignment is going to be found on page 612, and we will do this tomorrow in class. Thank you for watching day 2, video 2. Please watch day 3, video 3. I'm sorry, day 2, video 3.